Alright, let's look at the ODE practice exam 4, problem number 29. Alright, let's use Laplace transforms to solve this initial value problem. Alright, so from number 22, Laplace transform of g of t is given to be e to the negative s over s squared. Alright, so let's do that. Alright, we're going to apply Laplace transform to this differential equation. You get s squared capital X of s minus s times x of 0 minus x prime of 0, right? Plus 4 times Laplace transform of x is capital X of s is equal to Laplace transform g of t is capital G of s. Alright, so we got that. And since x of 0 is 0 and x prime of 0 is 0, so we know that we can just scratch those terms out because it's 0 anyway. Alright, so what you get is, alright, put those two guys together. So you have s squared plus 4 and capital X of s is equal to, right, g of s is e to the negative s over s squared. Right, so we can isolate the capital X of s by dividing through by s squared plus 4. So capital X of s is equal to, right, so we're going to have, let's see, I'm going to put e to the negative x in front. Then you're going to have 1 over s squared times s squared plus 4. Alright, then I'm going to apply the partial fractions. So you have e to the negative s, right? This one is actually kind of simple enough so that we can actually guess it. So we're going to have s squared on the bottom here, all right, and s squared plus 4. If I do 1 minus like that, then you see that you're going to have s squared plus 4 minus s squared. You're going to end up with 4. So I'm going to divide by 4. So you can double check, but this is going to be the partial fraction decomposition for this given function here. Alright, then we can apply inverse Laplace transform from here. So applying inverse Laplace transform, we get, right, x of s becomes x of t. So that'll be the solution of the initial value problem. Alright, so there's going to be 1/4, just going to be a number, so 1/4, right? So e to the negative s, that's going to correspond to shifting, so you have a u t minus 1, right? Then we find the inverse Laplace transform 1 over s, that will be t, but there's going to be a shifting, so I'm going to be a t minus 1, right? Here we have to do a little bit of tweaking. 4 I'm going to write as 2 squared, right? I'm going to put the 2 here, then divide by 2, right? So you will have negative 1/2. Alright, so this is going to be a sine of 2t. So you have a sine of 2t, but you have to apply the shifting, so we put the negative 1 there. Alright, so that is the solution of the initial value problem using Laplace transform. Alright, that's it. I hope that this was clear.